Hey guys, it's Colin from Brilliant Labs and welcome to my Unity 2D tutorial. So we're going to be making just a basic 2D platformer using Unity, and we're going to be using C# as the coding language. So if you don't actually have any experience with programming, that's completely fine. I'm going to walk you through every single step of the way. So first things first, we're at this unity3d.com. This is where we go to download Unity. It was really easy to get here. I just went onto Google and I typed in Unity download, Windows. We're going to click download, and then we're going to click choose your Unity plus download. We're going to want to click individual here, and then luckily if we do it personally we can get it for free. So I'm just going to say we're returning users because I know how to set up. Accept the terms, and then click download Unity Hub. Okay, so that's just going to take a minute to download, and then I'll be right back. Okay, so once it's finished downloading, just go down here to the bottom left of the screen and click the exe file. We're going to click yes, and then we're going to click I agree and install. So Unity Hub isn't exactly Unity, it's just like a program that Unity made so you can keep track of like what version of Unity you have. So we're still going to need to install it after this. But luckily we can do all of our installs now through Unity Hub. So to be able to start working, add a Unity version. So we're going to click add. And we're just going to use the latest official release. Okay, so this is important. Make sure Microsoft Visual Studio Community 2019 is checked. You need to install that in order to use C#. Then I believe everything else should be good. Cool, we're going to click next. Click the I have read and agree with the above terms and conditions, and then click done. So then we'll just wait for it to do its thing. As you can see here under installs, this just popped up. So it's going to have to download and install this, which is going to take a little bit of time. So just let that do its thing, and then I'll be right back. Okay, so now that everything's installed, you'll see it's right here. And we're going to click these three dots and then click show and explorer. Now it's going to pop up this unity.exe. That's where it's located on your computer. However, you don't want to go to like program files, Unity Hub, editor, etc. every single time you want to run Unity. So instead we're going to right click it, and you're going to see this send to, and you're going to click desktop create shortcut. And then you just double click Unity after you've created your shortcut, and then we'll just wait for it to boot up for the first time. Okay, so as you can see, I already have a bunch of projects. That's because I already had Unity on my computer. We're going to click new, and we're going to want to make sure we select 2D. And then we're going to rename this to 2D Platformer Summer Camp 2020. You can call it whatever you want, but this is just going to make it easier for me to locate. Okay, so that took a few minutes to set up for me, but now it seems to be all good. We're going to test things out real quick. So if we click main camera, this is automatically in our scene. Now, I know that everything here looks absolutely crazy. But don't worry about it, you'll get used to it, and as we go on, things will get much easier. But we're just going to right click in this gray part and click create empty, and then we're going to right click again and click rename, and we're going to name this our game master. So we're going to do a quick test to make sure that Unity is synced up with Visual Studio. So we're going to go to add component, and we're just going to type in game master, and it's going to create a new script, so hit enter, called Game Master, hit enter again. So we're going to be using this Game Master to control things like the score, but we'll get into that later. We just want to double click here for now under script, and it should automatically open Visual Studio for us. And then we'll wait for that to load. Okay. So there are two functions that are automatically in every single script that we create using Unity. There's this void start, which automatically happens as soon as the object comes into the scene. So Game Master's in the scene before we even boot up the game. So as soon as we boot up the game, start will get triggered. Then update happens every single time a new frame comes into play. So you've probably heard the term like frames per second. So if your computer is running the game at 60 frames per second, then it will call this update function 60 times. So all you really need to take from that is that this is going to continuously be the function that is called to update the game. But we'll get into that more later. For now, we're just going to type in debug.log. The game has started, semicolon, and then we're going to hold Control and hit S to save. And you'll notice up here, this gamemaster.cs, you'll see this asterisk or the star. That means we haven't saved yet. So if we hit Control S, it'll go away. And now we know that we have saved. Now if we go back to Unity, you're going to see this console. Everything that we do a debug.log on will come up in the console. So if we click play and then wait for it to load, you'll see that it pops up, the game has started. Now let's say we don't know where that came from. Obviously we do in this case because we only made one line of code, but you can double click it and it will automatically bring up that line of code in Visual Studio. So under our update, we can have another debug.log that can say the game is still running. And then if we save and then we click start again, you'll notice that it's happening over and over and over again. And if you look at this number over here, you can actually see just how frequently the update function gets called. Okay, so now we need to get some art for our game. Rather than actually creating that art ourselves, or just downloading it off of Google or something, Unity provides something called the Asset Store. And if we click this right here, we're able to download a bunch of different assets that other people have made. Some of these cost money and some of them are free, but luckily I found one that's really good for 2D platformers that happens to be free. So I'm going to type in 2D character into the Asset Store. I'm going to select 2D just to filter it out. And then we'll select this free assets so that it is all free. And then we're going to scroll down. Okay, so as you can see, I've already purchased this one, but it's technically free. So if we click it, then we can, oh, you downloaded, yes. So you might have to click something else like download or something, but it should be pretty straightforward. For me, I'm just going to click this import button, and it's going to automatically bring all of these assets into my project. So this is like this character, the ground, the background, the environment. So it's much more handy than actually creating the art ourselves because we're just the programmers right now. You would have somebody else on your team that is actually making that art for you. So I'll just wait until it imports all of this. And there, so if we go to our project folder and then we look at assets, we'll see scenes and Sunny Land. So Sunny Land is the name of the assets. Now scenes is basically like a level. So if you go into a new scene, you go into a new level. So they've provided a sample scene. And if we click it, well, there's actually nothing in the sample scene. So they just provided us with an empty scene, which is fine. But now we're going to start taking advantage of those assets. So if we right click here and then we click create empty, we're going to have a new game object and we're going to right click and then click rename. And we're going to type in player. Then we're going to go to add component and we're going to type in sprite renderer. Then just hit enter. Okay, so whatever we drop into the sprite section is going to make our player look like that. So if we go back to our project folder with player still selected, we can expand our Sunnyland, artwork, environment, I imagine, props, or maybe under sprites. Okay, so then player, and we're going to see idle. So that's what we want our player to be right off the bat, is our idle animation. So you can just drag this first sprite into there. Now if we go into our game, you're going to see we have our player. They are very small, however, so we're going to up the scale from 1 to about 3. And now we have our player. So the next thing we can do is create another new game object, and we're going to rename this to background. And we're going to add a sprite renderer. Back to our project, and let's go into props. They've got, oh, it's just in the environment folder. You'll see it's called back. Just drag that right on. So now we see we have this background. We can actually make that as big as we want. So if we make it 5 and 5, it'll do that. And then let's grab a new game object, and we're going to call that ground. So we're going to give it a sprite renderer. And then we'll go back to our project folder, go back to our assets, let's go into props. And let's find something that could be ground. So maybe this big block right here, or this platform long. So I still don't see it. Maybe I just have to make it bigger. Yeah, there we go. So let's make this maybe 6 and 6. Oh, that's a bit big. Maybe 4 and 4. Okay, and then we're going to drag the Y position down so that it's below our player. Okay, so as you can see, there's a lot going on. But we have game objects that represent something in the environment, such as our background game object, our character game object, our ground game object. We also have our camera, which we're not going to really be touching too much, and our game master, which will be handling like the time, the score, and all that stuff that isn't directly tied to an object that we can see. But you'll notice if we click play, nothing happens. And you might be expecting something to happen because we don't really know how video games work typically. But basically, an object has a bunch of different components that allow it to do stuff. So our player right now, for example, has a sprite component, but all that is a sprite component. So all that's done is drawn a picture onto the screen, and we haven't told it to do anything else. So in order to give it more functionality, we have to add more components to our player. So if we go back to player, and then we click add component again, we can type in rigid body. And we're going to select rigid body 2D. Now, a rigid body is a physics engine created by Unity. I don't know how it's coded. We're not really supposed to. They've just provided us with a way to utilize it rather than create it. So I guess let's just click the play button so I can demonstrate what that means. So we now have a player that falls because of gravity. If we scroll it really far, we can see it that it still moves. And basically all this has done is applied sort of like what you would imagine to be real world physics onto this player. So this player is now a physical member of our game. However, you're going to notice that it went right through the ground. And that's because even though our player now has physics, the ground is still a sprite. And in fact, even if we just add physics onto the ground, they still won't be able to interact with each other. And the reason is because we need something called a collider. So it looks like our player is colliding with the ground, but what's actually going to be happening is there's going to be a little rectangle around the player and a rectangle around the box. And when those two rectangles touch each other, it will tell Unity not to let them go through each other. So you might have heard the term collider in a video game before, but we're going to actually see exactly what that means. So we're going to go down to add component, and we're going to type in box collider 2D. And then we're going to go back to our scene, and we're going to click edit on our box collider. And then we're just going to zoom back into here. And you'll see that it figured out how big our sprite is and automatically applied a box collider to it. But it's not exactly where we want it to be. However, the main camera is on the same spot as our player, so it's hard to see. So we're just going to drag our player to the right a little bit. Great. So now we're going to make our box collider closer to the player. You don't want it to touch exactly on the player. You kind of want it to go in a little bit. So if an enemy, for example, was to touch our player, the game would recognize that because the enemy's box would be touching our player's box. So that's what that box collider component does. And if we go back to our ground, and we add a box collider 2D to that as well. Luckily, it already just fixed it for us. Now, if we go back to player and we bring them back to the middle and hit play, our rigid body will make us fall, and we will collide with the ground. Now, we're not able to move or anything yet, but you'll notice the player is a little bit above the ground. The reason for this is because if we go to our scene, our box collider is up to the top of the ground. But because it's 2D, we don't actually want it to be on the top. We want it to look like the player is in the middle of the ground. So we're going to drag our box collider down a little bit more so that it looks like they're standing in the middle. That looks a little bit better. So our game was running, so we're going to turn it off. And now if you turn it back on, you'll notice something. The box collider 2D has reset itself. And this is really, 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 really important. I've made this mistake countless times and I've lost hours of progress. If you have the game running, which it is right now, you can tell because this is blue, any changes you make are temporary. The second you turn the game off, all of those changes will get reverted. So if I go up to my player, for example, and I delete them, and then I turn the game off, my player is back. So if you go to make a bunch of changes, like let's say you make like a half an hour worth of changes in the inspector, once you have like 100 game objects, and your game is on, you will be very disappointed. So try really hard not to do that. However, there are ways sort of around this. If we go back to our ground with the game running, and then we click Edit Collider, and then we drag it down, now, let's say that took us an hour to do. Obviously, it just took 5 seconds. And we were like, oh no, I really do not want to recreate that game object. I can actually click the ground and right click and click copy or Control C, end the game. And then our ground is reverted back. But if we delete it and then just paste a new one in, it will be the one that was edited during gameplay. So now we have our player and we have our ground. The next thing that we're going to want to do is actually make our player be able to walk around, but in order to do that, we should probably have more ground, right? So you might be tempted to just copy and paste the ground and move it so that they connect like this. The editor is a bit finicky. And then maybe paste it. Oh, whoops. And then we'll copy and paste it again. There, that looks nice. However, this is not how we want to do it. I don't know if it'll do it right now, but sometimes it gets finicky. Oh, I can't move my player. Yeah. Basically, just take my word for it. Because this is a one-piece ground, basically, we only want it to be one ground, right? And because these 2 or 3 pieces are connected together, their box colliders are not always perfectly around each other. So you might get to a point where the player gets like to the edge of this and then gets caught on the corner of this next box collider. You do not want a bunch of box colliders on the ground next to each other like this. It will just completely mess things up in the future. So what we're going to do just to prepare for movement is we're going to have this one ground object, but then we're going to remove the sprite renderer from it. So now we have our ground, and all it has is a box collider. Now what we're going to do is rename this one to be ground sprite. And then we can just delete the second one. So now we have our ground, which is just a box collider, and our ground sprite. We're going to drag our ground sprite, or actually, we're going to remove the box collider off of our ground sprite. So now our ground sprite is just a sprite and our ground is just a box collider. Now we're going to drag our ground sprite onto the ground. So now you'll see this little arrow. We have just created what is called a parent-child relationship. So the ground is now the parent and the ground sprite is a child. And what's really cool is if we copy the ground sprite now, we drag it to, oh, that's so finicky, right about there. Then we'll make another one. That was 0.1, so we'll just drag it a little bit more to the left. That should be good. Okay, so now our ground has a one box collider that has 3 sprites. Now what we can do is make the parents box collider just stretch out to here. And there. So this is how we do it a little bit more efficiently. So we have our ground box collider, and there's only one box collider. It looks like there's 3 separate pieces, but it's actually just the same piece. Then we have 3 sprites on top of each other. So this way we don't run into a bunch of collision detection issues where they're touching each other. What's really cool about parent-child relationships is you can do something to the parent that can affect all of the children. So for example, if I decide I don't really like that my ground is right here, I can move the parent ground and it will move all of the children inside of it as well. So now that we have the ground working in the player, we should just be able to drop it. Let's just double check everything still works. Okay. So I know this is probably quite a bit to take in, but for the last part of this first video, we are going to make our player just be able to walk around. So we're going to click Add Component, and we're going to add a new component called Player Controller. The word controller is used in programming when we want to control things. So it is just a standard that is typically used. So we wouldn't want to call it like player something else. Like player controller is typically what actual industries would just call it. So we're going to enter and enter again. It should automatically add our player controller here for us. So we're going to double click it. And then we'll wait for it to open in Visual Studio. So we need to do just a quick lesson on variables. So variables are something that you can store, like a value, inside of a word. And when you type in that word again, the computer will know what you're talking about. So for example, in the start function, if I declare a variable that is a string, which is a line of text, name equal to colon, we now have a variable called name that holds the value of colon. So if I do another debug.log and I put name into it, and then if we go back to Unity, oh, I just realized the game manager script that we had before is still going to have these debugs, so we can just delete them from there. Then if we go back to Unity and we click the start button, it'll say colon. So there are a few different variable types that we're going to be using. We're not going to get into all of them right now, but I figured that I should go over some of the important ones. So I'm just going to comment these out. And what commenting does, it's just 2 slashes, and it makes it so that the computer doesn't actually run the code. It's just there so that we can read it. So we're going to have a string name equals colon, and I'll have a comment, a string is a line of text. Then we're going to have int age equal to 20. So I'll add another comment. An int is a whole number, such as 0 or 1. The next one is going to be a float. A float is a number that can contain a decimal, such as 0.1. So we'll do like float price equal to 3.99. And then our last data type we're going to go over with is a Boolean. And a Boolean variable can equal true or false. So an example, we can have bool player is alive equal to true. Okay, so hopefully that made a little bit of sense. If not, you can experiment with these. So you could declare a variable down here, like I've typed up there, like int age equal to 20. And then in this debug.log, if you put in age, it would debug 20. So all you need to know is that variables hold values that we use in computer programs in order to keep track of different values. So our first value that we're going to create is a float called move input. We're going to set it equal to 0. Then we're going to create another function alongside this called void fixed with an uppercase F update And fixed update is a function that is called in Unity automatically, similar to update, except for we want to call fixed update whenever we're dealing with a physics engine. So for example, our rigid body that makes our player move is a physics engine. So if we want to move our player, we have to call all the code to move the player in fixed update. So I'm going to add that comment so that you guys can remember that later. Fixed update deals with anything related to physics, rigid body, such as moving the player. So now we're going to type in move input equals input dot get axis raw, and then in quotes we're going to put horizontal. And basically input.getAxis raw is a function created by Unity that will determine what key you're pressing down. So horizontal, for example, if you're pressing the right arrow or the D key, will return 1. And if you're holding the left arrow or the A key, it will return -1. So if we're holding right, or we want to go right, then it'll return 1. And if we're going left, it's -1. If it's 0, then that means they're not touching any keyboard key at all. So then up here, we're going to have another variable called int speed, and we're just going to set it equal to 4. And we are going to make it public. And I'll show you guys what that does in a bit. So then we need to reference our actual rigid body component in this code. So we're going to type in public rigid body 2D, and we're just going to call it RB. And then because if we go back to Unity, sorry, it's being a little bit laggy. Because our script of player controller is attached to the same object that has the rigid body, as you can see right here, what we can actually do is just reference it by typing in RB equals get component rigid body 2D. I know this looks a little bit weird, but so we're able to reference any component attached to this object this way. So we could do like get component box collider if we need to reference the box collider or something. But right now we're just referencing the rigid body because we need to use the rigid body to make our player move. Because again, that's the physics engine. So to make the player move, we're going to do RB dot velocity equals new vector 2. Now a vector 2 is basically 2 points, an x-axis and a y-axis. So if we go back to here, our vector 2 for the player is -0.03 and 0. So we move this, our vector is now -0.03 and then 0.33. You might be wondering, well, what about the z-axis? However, we're not actually doing a 3D game, we're doing a 2D game. So we only need to use vector 2 to represent both the x and y axis. So the x-axis is left and right, and the y-axis is up and down. Just like that. So if we want to change our character's location, we need to update the vector 2. And it will be referenced as a transform. So we'll go over that. So we're going to do rb.velocity equals new vector 2. But remember, if we're using the left or right arrow keys, we want to move left or right, which is on the x-axis. We don't want to actually move up or down on the y-axis. So we're going to keep our y-axis at the exact same velocity that it already was, rb.velocity.y. So it's going to say grab our current y velocity and set it here. It's the x-axis that we want to change when we're moving. And in order to do that, we just have to type in move input times speed. So our speed, so remember our move input is going to be 1 if we're going right, and it's going to be -1 if we're going left, or it's going to be 0 if we're not moving at all. And then speed will multiply by 1 or -1 and will make us go farther one way or slower one way. So if you want to decrease your speed, you just drop this number. And if you want to increase it, you just make the number get bigger. So we made speed public because if you make a variable public, it will pop up in the inspector under your controller. So as you can see, we can edit the speed variable right here just as we have the rigid body right here. And you'll notice if we click play, the rigid body will call the get component code and it will reference the rigid body that's here. And our speed is 4. So now, if we use the arrow keys, we will move. And remember, the reason why is because like move input is saying, okay, 1 times 4, and then we're going to move our x-axis in a positive direction at the speed of 4. So if we change our speed in the middle of the game to like 1, and then we move, you'll notice we move much slower. Another thing is too, you'll notice that it's facing the exact same way, whether we're going left or right. We're going to fix that obviously in the next video. But for now, I thought it'd be really awesome to just start at the very first video